MacMaths, MacMaths, let's do some maths today. Okay guys, back with you. So for this lesson, I've put lesson 2A, so it's a supplement to my last one, a very short one, just explaining the I and the J notation and the column vectors. And I'm going to go through selected questions for you to support you doing 11B. There are some tricky questions in there now, so if you've not seen these before, then this will help you. You might want to go through the questions and have a go at them, and then just put this on pause. And then watch me do them and so on, and then have a go at the next one. I am going to go through a few of them, but I'm going to jump. I think the first ones are fairly obvious. I'm going to jump straight in at question 4A. Over the years, when this is in the old books as well, this question, students have struggled straight away with this, and I haven't had a class where they haven't struggled with this particular question. So I'm going to go through questions sort of 4, 5, and I've got some others, sort of 7, 8, 9 and 10 and so on. So, okay, here we go. So question 4A says, given that A equals 2i plus 5j and B equals 3i minus j, find lambda. So they use this Greek letter. They like to use lambda and mu. You'll see these coming up. Find lambda if A plus lambda B is parallel to vector I. Okay, so let's work out A plus lambda B. So this is saying A is 2i plus 5j, and we're adding some multiple, so lambda times 3i minus j. So this sentence here, A plus lambda B, is A plus lambda B. There it is. Now, what we can do with this one is we can multiply out this bracket. So 2i plus 5j plus, and just like we would normally, 3 times lambda, lambda times 3i is 3 lambda I minus lambda j. Okay. And we want to change this into one vector in the form of ai plus bj, so some number in front of I plus some number in front of j. So we do that. I always do this now, is I always do the extra step. So write all your i's together. So we've got a 2i and we've got a 3 lambda I, so that's that one and this one. And your j's together on the end, because i's come before j, so 5j minus lambda j. Okay, it doesn't matter which way around they go, and it doesn't matter which way around they go. But the i's are first before the j's. And then if we factorise out just the I and the j, so if we factorise out the I here, we've got 2 plus 3 lambda. Now instead of putting normally we put the number at the front, don't we, of the bracket, but I'm actually going to put it at the end, and that's because the I goes there after the number. The number in this case is actually quite a mouthful. It's 2 plus 3 lambda, whatever that is. Plus, factorising out the j, we get 5 minus lambda j. You can see that this now, it multiplies out to that, which rearranges to this, which came originally from this here, which is this sentence. So quite, a lot of work to do to get to this point here. But now we're at this point, we can answer this, because it says that this vector, which we've written now as this, is parallel to vector I. Well, vector I, is one unit in that direction. Okay, so parallel to that is I itself, or 2i, or 3i, or 4i. Okay, but they're all going in that direction. They're all parallel to I. And what none of those have got is none of them have got any j part to them at all. Okay, so they're all I plus 0j, because if they had any j, they wouldn't be parallel to I. They'd be going up a little bit as well. Okay, so in other words, from that, okay, we're saying for this to be parallel to I, then there must be no j. Okay, so in other words, this bit here, 5 minus lambda, has got to be equal to 0, hasn't it? Okay, when that is equal to 0, okay, then we've got a vector that is parallel to I. And in fact, you can see here that it happens when lambda is 5. When lambda is 5, this is 0, this is 17i. So this, when all of this when lambda is 5, we get a value of 17i only for this bit here, which of course is parallel to I. It's just 17 times longer in the same direction. So lambda has to be 5. Okay. There's a part B to that, but it just says when it's parallel to the j. Well, obviously it's parallel to the j when the I part is 0. So whatever in the brackets that uses a different one. I think it uses mu for that. Okay. So that was 4a. Question 5 builds on that. Okay. And question 5 just complicates it a little bit. Here we go. And there are 4 parts to this, but I'll do the first 2. And I think after I've done the first 2, you'll then be able to go on and do C and D. So I'll do A and B with you. Okay. Given that C is 3i plus 4j and D is I minus 2j, you've got to find lambda if C plus lambda D is parallel to I plus j, to the vector I plus j. Okay, well, let's just work this out. The same as we did before. So we'll do part A. C plus lambda D is 3i plus 4j plus lambda times I minus 2j. Multiplying that out, and we get 3i plus 4j plus lambda I minus 2 lambda j. Okay, 3i plus lambda I plus 4j minus 2 lambda j. Don't do it as quick as me, I'm a trained professional. Okay, and then if we factorise that out, we get 4 minus 2 lambda j. Okay, so we've worked out C plus lambda d. Okay, so C plus lambda d, and we've multiplied it out and we've simplified it like I did the first one. We've got down to this now. Now that they're saying that this is parallel to the vector I plus j. Okay, and I plus j is 1 along and 1 up. Okay, there's I and there's j. So in other words, it's parallel, it's going in that direction, isn't it? Okay, it's parallel to that. Okay, and that happens when it's going to be parallel to that, isn't it? When the I is the same as the j. So 1i equals j, or 2i equals 2j. 2 along and 2 up would be parallel to that, or 3 along and 3 up. So as long as the I is equal to the j, it's going to be parallel to I plus j. So therefore we solve this by saying, in this case, 3 plus lambda must be equal, whatever's in front of I must be equal to whatever's in front of j. Okay, I'm adding 2 lambda to both sides, so I get 3 lambda, and I'm taking 3 off both sides to get 1, just solving a normal equation, and divide by 3, so it happens when lambda is a third. Okay, this one, part B. It says find mu, so it's used this symbol now, if mu c plus d is parallel to I plus 3j. So if we do this one, it'll allow you to be able to do c and d because they're done in a similar way. So let's do this one, mu c, so that is mu times c, which is 3i plus 4j, and that's plus d, which is I minus 2j. There we go. So I've written that out, multiply it out, so I get 3 mu I plus 4 mu j, so all I've done is multiplied out my bracket, plus I minus 2j, don't need the bracket around that. Get my i's together, 3 mu I plus another I, that's that one there, plus 4 mu j minus 2j. So I've got my i's over here and my j's over here. Factorise out my i's. 3 mu plus 1 times I plus 4 mu minus 2 lots of j. Okay. And it says this has got to be parallel to I plus 3j. In other words, 1 along and 3 up. I and 3j. So it's got to be parallel to that. Okay. It's parallel to this, okay, when this value here is 3 times the I value, isn't it? So if we take this value and times it by 3, we get that. Okay? Alright? So as long as 3 times this is equal to that, okay, it's going to be parallel to this vector, isn't it? Okay? So 3 lots of this, 3 lots of 3 mu plus 1, so in other words 3 lots of I would be equal to 3 lots of 1 would be equal to 3, wouldn't it? It's got to be equal to 4 mu minus 2. So 9 mu plus 3 is equal to 4 mu minus 2. And I hope this is on your page. Take off 4 mu from both sides and we get 5 mu and is equal to minus 5, and so mu is equal to minus 1. Okay, so we've got that one solved. Okay, I'm just going to check that one's in focus. It is. Okay, so you've got that on your screens. So you can see how we did this, a little bit more thought going into it, but I hope you understood that, and that will allow you to do C and D. Okay. All right, I'm going to jump question 6 because it's fairly simple, and question 7 is a little bit harder. So I'll go through question 7. When I say a little bit harder, I'm not meaning it's hard, it's just harder than question 6. So this one is one of those sort of diagram ones again. It says that, it draws you the diagram in the book actually. So so this is the parallelogram OABC. They often use O, so that implies it's on, you know, on a set of axes, doesn't it? And it's starting, you know, this is the x-axis and this is the y. They often do this, so they've drawn it sort of sat on an axis, if you like, because we normally label the origin O. And so you'll often see this here, OABC, like that. They've said that P divides AC at the ratio of 3 to 2. So this is the 3 and this is the 2 here. So essentially from a couple of lessons ago, you know, if you go in AC, then P is 3/5, isn't it, along AC. Going from there to there, there's 5 parts altogether, and that is 3/5. So AC, A to C is going to be, if you want to go from A to C, you've got to go minus AO. So OA from there to there is 2I plus 4J. So we want minus OA, okay, minus OA plus OC. Okay, so minus OA is minus all of that. So minus 2I plus 4J plus OC, which is just 7I. There's no J element to that because it's just horizontal. So that's minus 2I minus 4J, multiplying out by minus 1, minus all of that. That's what it is. It's like minus 1 times all of that, plus 7I, and minus 2I plus 7I is 5I. So we get the i's together first, always, minus 4J. Okay, and that is describing from A to C, 5I minus 4J. We've put you bang on the money there. Okay, so that's our AC. If I do AP, So A to P, like I've said, it is, that is 5 parts altogether, and if that is 3 to 2, then it's 3/5, isn't it? So AP is simply 3/5 of 5I minus 4J. That's what AP is, okay? You can multiply it out, okay? So 3 times 5 is 15, divided by 5 is 3, 3I minus and 12/5 J. So it can be written like that also, AP. I think in the book, just to get you used to it, it does say write them in the column vector. We were talking about column vectors. You know, in the answer for that in the column vector, of course, is just 5 over minus 4. You could write it like that. This as a column vector is just 3 over minus 12/5 as a column vector. That's all it's saying. And OP, okay, the last one is just going from there to there, okay? Either way, but because we've got AP, it's quicker to go that way and then down rather than along and then back up, okay? Because this would be minus 2/5, wouldn't it, of AC. Okay, so we're going to go up to there and down there to get to go from O to P. So OA would be 2I plus 4J, and we're going to add to that AP, which we've got 3I minus 12/5 J. Let's just do it in a different form now, just because we've done it all using I and J. Let's go with the column vectors. So OA is 2 over 4 plus 3 over minus 12/5. Okay, and we just add them up, don't we? So 2 add 3 is 5, and 4 minus 12/5. Oh, do you know what? I can't be bothered. 4 minus 12/5. There was a time when I could do all of this in my head. Is 8/5. There you go. And that is OP. Okay, or 5I plus 8/5 J. Okay, whichever one you want. Okay, so column vector I and J, and that's question 7. A few more. Okay, so put them on pause and have a go at the next ones. A bit disappointed with the book actually with the next one. I'll explain why. You won't think it's strange at this point, but if you've done the mechanics, you may find this one strange. Okay, so they've gone to the column vectors version of it. That's okay. I'm not happy that the letters that they've chosen, the unknowns that they're wanting you to find here, is a J there, because we use I and J to that. So you wouldn't see this on an exam. It wouldn't pass quality control. They'd pick a different letter here. Also, they've used K, and when we look at vectors in the I and J form, we also use K for 3-dimensional vectors. So you'll see like I, J and K for along the corridor, up the stairs and out into space. The K is the 3rd dimension that makes that gives us 3-dimensional vectors. Or you'll see AI plus BJ plus CK. Okay, I, J and K in 3-dimensional vectors. However, let's stick with it. They're saying B minus 2A. Okay, so B is 10 over K. There it is. Minus 2A, minus 2 lots of A, which is J over 3, is equal to C, which is 2 over 5. Okay, so they've gone away from I and J. So let's just work this out. 10 over K. Multiply both of these by minus 2, so it's or 2 is 2J over 6, so minus 2J over 6, so just multiplied out that is equal to 2 over 5. Okay, so that is A It's not. It's b minus 2a. Okay, is equal to c. So that's what we've got written down there now. Okay, and you can see what we do. You can just see that 10 minus 2j is equal to 2, the top row. Okay, so that's to solve. So 2j over there, 2 over there is 8. So you can see that j is 4, and 2 4s are 8. So we've got j, and the bottom row also we've got k minus 6. So k minus 6 must be equal to 5. Okay. So you can see that k is 11. Okay, so 11 take away 6 is 5, and so on. So that one's okay. I don't think I need to go through fully number 9 with you now. It is a little bit harder. Okay, if you look at number 9, they've got p over minus q and q over p, and those are numbers. Same thing, just set it up. P minus q. We've got p minus q, that's a, plus 2 lots of that. So plus 2 lots of this, 2b, is 2q over 2p. I'm not going to do this one. And that is equal to c, which is 7 over 4. So you've got to find out what p and q are. You can see that p plus 2q is equal to 7, and minus q plus 2p is equal to 4. Okay. First of all, you can just switch that round, can't you, and write that as 2p minus q is equal to 4, and we've got a p plus a 2q there is equal to 7. And you can see it's just a pair of simultaneous equations. You know, you double the bottom one and you can take away to eliminate and do it that way, or you can do it by substitution. 2 equations, 2 unknowns. It's GCSE simultaneous equations, isn't it? Okay, so we won't finish that one off. But number 10 is a little bit harder. Okay, so I'll just go through number 10 with you. There's that word resultant again. The resultant of vectors a and b, the resultant of vectors a and b is parallel to the vector 2i minus 3j. Remember that resultant means added together. So this is saying 3i minus 2j add pi minus 2pj. So those two added together, that's a plus b, and that is parallel, not equal to, but parallel to c, which is 2i minus 3j. Okay. Let's add these two together then. Get our i's together and get our j's together. So I've just switched those two around effectively, haven't I? Factorise out. Factorise out. Okay, so we've got i's plus our j's. Okay. And this is parallel to 2i minus 3j. Now we could do it the same way as we did earlier. We could look at what we do to get from 2 to minus 3 and apply that same rule here. We divide it by 2 and times it by minus 3, don't we, to get from that to that. So we could apply that to this and put it equal to that when we times that, divide that by 2 and times it by minus 3. So minus 3 over 2 divided by 2 and times by minus 3. Lots of that has got to be equal to minus 2 minus 2p, and multiply that out and solve it that way. I'm going to do it a slightly different way for you now. Okay, so think about this. If it's parallel to this, then it is some multiple of this, isn't it? So it's 2 along and 3 down. Okay, that's 2i minus 3j. So it's some multiple of that vector from there to there. Okay, if we say some multiple of this, I'm going to use what they use a lot. They say lambda 2i minus 3j, where lambda is some multiple of 2i minus 3j. You often see lambda and mu used in vector forms. So what we're saying is that this now is equal to lambda times 2i minus 3j. So this is equal to some multiple. If it's parallel to it, then it's equal to some multiple of 2i minus 3j. Therefore, if we multiply this out, 2 lambda I minus 3 lambda j. So this is equal to 2 lambda I minus 3 lambda j. In other words, if it's equal to it, then 3 plus p, what's in front of I here, has to be what's in front of I here. And in front of I here is 2 lambda. And minus 2p, and the j has to be equal to what's in front of j here, which is minus 3 lambda. So this happens when the i's are equal and the j's are equal. Okay. And you can see here that we've got two simultaneous equations. Okay. If I was to solve those simultaneous equations, I'm not actually interested in lambda, I'm not interested in what multiple it is. So I can find p and lambda, but I'm only actually interested in p, which is what the question is asking me. If I double the top, so I times this by 2, okay, I get 6 plus 2p is equal to 4 lambda, and if I write underneath it, minus 2 minus 2p is equal to minus 3 lambda. You can see why I did that. Well, I hope you can. Okay, because I've got the same coefficient of p now, and if I add them together, I've got a plus 2p minus 2p, which gives me the 0, which is what I was after. 6 add minus 2 is 4, and 4 add minus 3 lambda is lambda. So lambda is equal to 4. Okay, so now we know that lambda is equal to 4. We've got 3 plus p is equal to 2 lambda. We know lambda is equal to 4, so 3 plus p is equal to 8, so p is actually equal to 5, isn't it? So now we've found p is 5, and the resultant of a and b, well, the resultant of a and b is just that plus that, isn't it? Where p is 5. So where p is 5, is that what that is? 3i minus 2j plus 5i minus 10j. So that's all you're doing. So 3 plus 5i, so that's 8i, which I had there actually. Hang on, you won't be able to. So we've got 8i, so this is for this one, and minus 2, p is 5, so minus 2 minus 10 is minus 12. Minus 12j. So that's the resultant of a and b when we know that p is 5. Okay, so that was a slightly different way of looking at it. It was a trickier question, that there was quite a little bit to do. The maths was simple enough, it's just the understanding of it, so you might want to rewind and watch that one again. So I hope that helps you with the exercise. Number 10 was the most difficult. It was also the last question in the exercise, but have a go at them before you watch this video, okay, and message me through Show My Homework if there's any problems, and we'll speak directly over that then. Okay, thank you.